Yeah. Okay. So let's get started. The agenda of today, bearing in mind that this is a cloud practitioner level, I always want to start with some basic. So we have what's an IP address, subnetting, we then go on to VPC, and then start looking at the components of VPC, which is mostly subnets, NACL, security groups, NAT gateways. Then we'll talk about connecting your VPC to on-premises. That comes with VPN and direct connect, VPC peering, and a lot more of other components that come with networking, right? So you'll be able to get used to them as we go along. So let's start with the basic, just to make sure that I know this could be just obvious for some of you, but in case someone joining and not very used to what is an IP address, so let's just define that. We see that often, but what is it really? So it is a unique identifier assigned to a host. This could be a computer or any device that you find in a network, right? And bear in mind that an IP address is actually a soft address. There is also something known MAC address, which is more of hardware. So it's encoded. So while IP address is a software address, the MAC will be hardware address. And what's the use? What does the IP address do? It allows a host on one network to communicate with a host on a different network. So that's just a basic definition of an IP address. But what is the structure? We've seen, for example, 172.116.254.1. But actually, it gets interesting when you look at it from the binary notation. So IPv4 always consists of 34 bits, and all of them divided into, you have 1 byte. 1 byte is made of 8 bits, so you always have it divided into 4 sections. This is very important when we start looking into subnetting, which is a very important component in the VPC structure, right? So you have an IPv4 address always made up of 32 bits and divided into 4 sections, as shown here. This is an example, right? So the convention is always the network part and the host part. We touched on that. So a subnet mask will help you determine which octets belong to the network portion and which octets belong to the host portion. So as you have seen the IP address in the previous slide, there's a particular portion that will belong to the network portion and a particular portion that will belong to the host portion, because you always have a network, and in that network you can place particular host. So the question is, which portion will then belong to the network? So you have, for example, if you have an address with notation 10.0.0.1/, this is the subnet part here. This portion 255 here shows that the first octet belongs to the network, and the remaining portion will belong to the host section, right? So you can always write it in this format, or you just write it in this format. So this is the most common written format. /8 here will mean that the first 8 bits are belonging to the host portion. Or if you see a /16, it means that the first 16 bits, which means here, will belong to the host, and the remaining 16 will belong to the host portion, right? And then you have what is always private IP and public IP addresses. Just remember that private addresses are not always routed on the internet, and no traffic can be sent from them from the internet. They're only supposed to work within the local network. So you have what is called a local network, and then you have public addresses. These are the ones that are used to communicate. You use them on the internet. So there's this difference between private and public addresses. Of course, you have different classes of addresses. The way it is designed, you have class A, and these classes, you can always know how different they are based on the bits that are associated to the network. and the bits that are associated to the host. So class A addresses will always have the network bits in the first 8, and the remaining 24 will belong to the host. The same will be for class B will be for network will be 16, host will be 16. And the range, and you can see the range span from 128.00 here to 191.2500. So this starts giving you an idea. When you see an address, you start thinking which class does it belong to, right? And you see for class C, 24 will belong to the 24 bits will belong to the network portion, and 8 will belong to the host portion, right? So that was just kind of touching on these basics, and then bear in mind that class IPv4 addresses kind of running out, and then of course the new format IPv6, which is made now of 128 bits with the high increased use of addresses. IPv6 gives that opportunity for you to go as far as we can have as trillions of addresses, so it can accommodate the current world where there's just a high demand of IP addresses. But most of what we'll do today will be around IPv4 addresses, right? So that was just a touch on IP addresses, just to make sure that for those who are not familiar, they get used to. But then let's look into subnetting, which is a very important aspect when you start doing looking at subnets on the VPC. You always have an address block. This is, for example, a class A address. Remember, /8 here will mean that the first 8 bits will belong to the network portion. So the network ID will be represented by 10.0.0.0. And the first host in this network address block will be 10.0.0.1. The last host will be this, the broadcast will be this. There's an internet page that you can always use to get this information. I'll share that later on. And how do you calculate the number of IP addresses in a particular network address block as well, right? So in this case, this network address block will give you this number of hosts, which is 2 raised to the power of 24. That means the remaining 8 bits here. So 24 is the number of hosts. That's how you get that. So that's how an address block will look like. So what is then subnetting? So subnetting is when you take an address block and then you want to you have a network address block, you want to create subnetworks. That means you want to split that network into smaller subnets. Basically, what we are doing is you are borrowing some bits from the host portion to use to create those networks. So for example, if I have this address block that I just referenced, I've decided to put it here in bits just that it should show more clarity. If I want to subnet this address block, remember this is representing 10.0.0.8 here. I can then, this is the host portion. I decide to take 8 bits from the host portion. Now it means that I have now 16 bits that I'm going to use for networking, and the remaining 16 will be for the host portion. So subnetting is borrowing bits from the host portion to create subnetworks. So you just have a big network and you create that into subnet. And you can calculate the number of hosts you can have in each subnet that you create by doing, it will be 2 raised to the power of 8. So those are the number of bits you have borrowed. That will always give you the number of subnetworks you can create. And then the number of hosts that will belong in each subnet will be 2 raised to the power of 16 here, right? So that's just how you calculate that. But this can always be a bit tricky to always have that number. There's a nice subnet calculator online where you see if you put your address block here, you put the subnet mask, the new subnet mask you want. So I'm borrowing 8 bits from the host, so I'm using slide 16 now. Will automatically just fill in the number of hosts, the number of subnets for you, and then it will list all the subnets. So it starts from 1 to 256. So there's 3, 4, 5 in the middle here, and it will give you the range. So it's a very nice calculator you can always use for that. Right, so So that is that on subnetting. I have an assignment here. You can look into that later. Just imagine how many subnets you can have. Yeah. So key takeaways: IP address is made up of a network portion and a host portion. IPv4 has 34 bits divided into 4 portions of 8 octets. IPv6 is made up of 128 bits, and subnetting is the borrowing of bits and subnetting it to create more subnetworks. That was all about IP. Any questions or anyone? I know this may be some fundamentals, but anyone having issues with the basics or fundamentals of networking, but if you have always had questions that need clarity, we can touch on that. Okay, I think we are all good, which is then nice. So let's go ahead and talk on VPC, which is the topic of today. Virtual private cloud. What actually is that? VPC stands for virtual private cloud. VPC is actually a virtual network, which is more of a data center dedicated to your AWS account. In the traditional IT, every company will always have its own data center before the coming of cloud. Every company had it kind of a data center. So think of a VPC as a virtual data center. It is somewhere there out of the cloud, right? And it's logically isolated from any other virtual networks in the AWS cloud. So when you think of AWS cloud, I'm sure that you must have done the global infrastructure. So when you think of AWS, it's just a huge network that belongs to AWS, right? So in that network, AWS will give you that possibility to create a virtual network that belongs to you. And this will be isolated from any other networks that are created. So, and this network gives you kind of a control over the virtual networking environment, including the resource that you want to place on it, the connectivity and the security that you want to do as well. And for every VPC that you create, you always require a name and a CIDR block. We have just talked about CIDR block in some the fundamentals of IPs there. And the normal minimum that you can use is the /28, and then the maximum is the /16. So for a VPC in AWS, you always need a name, and then you always need a CIDR block. So remember, virtual private cloud is a virtual network, or call it a virtual data center that is dedicated to your AWS account. And for a format here, you can look into this as you have the entire AWS cloud, which is again just a network that spans the world globally. And then you can go into this physical network of AWS and create a logical network here, which is your virtual data center. For example, here you have a VPC with name VPC-A. You can see it has this CIDR block here associated to it. You have another VPC here called VPC-B with a CIDR block associated to it. So the IP addresses that will belong to this VPC will come from this CIDR block. So VPC-A, VPC-B, VPC-C here. And I just mentioned here that they are non-overlapping. Non-overlapping means that the addresses in this network are not, you can't find them in here. They are different, right? So they all have distinct IP addresses in each of the networks. And this is very important when we start looking into other concepts. So this is how your VPC will look like. In AWS, you are allowed to create a maximum of 5 VPCs in each AWS region. Take note of that. And in each, when you have created an AWS account, there's always a default VPC. So AWS has a VPC that's already existing there using the CIDR range 172.31.0.0/16. Right? So when you create an AWS account, you will immediately see that there's a VPC existing there. But you can then create custom VPCs, which is what is recommended, especially when you start doing production workload. This can just be for normal testing purposes. But this soft limit of 5 VPCs, if you happen to need more, you can always ask AWS to increase that number. Each VPC will support about 200 subnets. There's no charge for creating a VPC, but the resources that you place in that VPC will definitely be charged for, right? So that's some of the features about AWS. Let's look into the components now that come along with VPC. So having talked about what VPCs are, let's look at VPC subnets. And we already discussed that should go in front. A subnet is a range of IP addresses in your VPC. We'll discuss what subnets are all about. So you can create AWS resources such as EC2 instances in specific subnets. So when you create your VPC, and if you happen to create subnets inside that VPC, that is where your resources in AWS will live. For example, EC2 instances, right? Or if you have a database instance, they live inside your subnet. And one thing is, subnet reside entirely within one availability zone. You know, the global infrastructure, you always have a region, and then in region, you have availability zones. So subnets reside within one availability zone and cannot span more than that. And an AZ can have more than one subnet, but a subnet can belong to just one AZ. Now, the subnet type is determined by how you configure routing for your subnet, which is what we're going to look next. What are the different type of subnets that you have on AWS in your VPC? You have what is referred to as the public subnet, and what means, just as the word public says, it has a direct route to an internet gateway so that your resources can be able to access the internet. So resources in the public subnet are able to access the public internet. So when you think of a public subnet, you just think of the public internet, you think of an internet gateway, a route pointing from that subnet to the internet gateway, and we'll talk about routing shortly. When you talk about a private subnet, you're thinking of, it does not have a direct route to the internet gateway, but there is something called a NAT gateway that we'll also talk about. So resources in your private subnet will always require a NAT device to be able to access the internet. There are other subnets that may hardly mention, like VP-only subnet, and this is just when you are doing site-to-site VPN connection using a VP gateway. You have also isolated subnet. These are subnets that has no routes outside its VPC. Hardly talked about, but you may come into cases that you need them. So that is just a general rundown of the different subnet types that you have in your VPC. So let's look at some reserved IP addresses in AWS. So remember, when you have a network block, there's of course the network address that refers to the network itself. But then there is the first IP address you always have in the network always belong to the AWS VPC router, a virtual router that sits in your VPC. You have this next second address, which is the .2 address, is reserved by AWS for a DNS service in the VPC. Then you have the .3 is reserved for feature use, and the last address is for network broadcast address, which is not currently used in AWS. So when you look into it, it's important to always know what these reserved IPs are, so that when you have your network, you should then know which addresses, for example, you can be assigning to your host in that particular subnet. But let's look at it in a picture format. I think that's always helpful. So you will see here, when you have a region, so AWS, again, you think of a region, and then you have, this where a VPC is actually a regional service. And when you create your VPC, then you have a public subnet, which can be sitting in a particular availability zone. You have a private subnet, which can be sitting, again, just under here. And the difference with this public subnet, as we mentioned, is there's a route entry here that points to the internet gateway. That's just what makes public subnet different from a private subnet. Yeah. Any questions so far? Just to make sure that everyone is there. Or comment. Olivier, let me know you're hearing me.
Yeah, I can hear you. So far, so good.
Okay, thanks. Okay, just to make sure we're together. Right, so yeah, so those are fundamentals of the VPC. We've talked about subnets. So let's look at routing and route tables, which is where we always start. How is traffic moving? How do you have traffic move from one network to another? Every VPC has a router, just like you have a router. For those who know how this looks like in a normal traditional data center, but you hardly have anything to do with this router. It's a highly available router managed by AWS. The key thing that you really look into is your VPC router is controlled through route tables, and this is where most of the work. When you're trying to run your traffic, you always go to configure your route table. So the router itself, the VPC router, has an interface in every subnet. It's helping to route traffic between subnets. And there's a main route table, which is this kind of subnet default. So when you create a subnet, if you don't immediately take this main route table, but in general, recommendation and best practice is for you to create custom route tables that you can then associate to your subnet, and then you'll be able to show how to move how you configure your route tables to be able to move your packets the way you want. I think at this point, maybe it would be nice just to show how that would look like on AWS. At times it's always good. So let me just bring I've signed in. I'm here inside my AWS console. If you look here, I can come to the VPC dashboard. So if we're talking about VPCs, once you sign on your AWS account, the service is VPC, isolated cloud accounts. If you clicked on it, you have a dashboard representing all the VPCs you have. So if I click on your VPCs, as I mentioned, this comes by default. You always have a default VPC. Yeah, you see it says default VPC. I hope this is quite clear, right? So you have a default VPC that exists already on your subnet. You can see the IPv4 address range, but as I mentioned, you can go ahead and create your own VPC. So if I were to click on create here, I'll go ahead and let's say my test VPC. You always need to give a name as a minimum. You can then specify the CIDR range, which is what we were just talking about. So I could give like 16 as my CIDR range. You can, the other ones by default, you can allow them as they are, and you go ahead and just create, right? So that's just how you can create your VPC. This is it here. And if you saw, this is a custom VPC, which is what is recommended when you are doing production workloads. And you can see that under default VPC is listed as no. You always have a VPC ID. And if you notice, this VPC here, it doesn't yet have a route table associated to it, but you notice the default VPC has a main route table associated to it. So you can come here now and create subnets. These subnets are the ones that belong to the default VPC. If you notice, there are a series range of IP addresses existing here. They belong to the default subnet. So what you can do is you can create your own subnet. Let me see. We have just created our own subnet, our own VPC with 10.0.0/16. I want to show you this IP calculator that I mentioned earlier on, how you can quickly subnet that. So if I do /16, sorry, /16, this is my current address block. Let's say I want to subnet it by borrowing 24 bits, right? So I'm using 8 extra bits. You see, it immediately gives me the number of host subnets I'll have, the number of subnet that will be created. And it gives me the different subnet details here that I can just use now to create my subnet. So for example, I have here, this is the first subnet. This is the subnet address, the first one. So I can go now and I create subnet using this information here. So just take note of that. So what I'm just going to do here, let's create some subnets. I'll have to choose the VPC. So I'm using the my test VPC. I'll give a name to it. Let me say my subnet A. I will allow availability zone, as we said, it subnets sit in a particular availability zone. Let's just pick the first one. Now I have to enter the IPv subnet that I'm using here. So I will use /24 because I've borrowed 8 bits from the original host portion for my subnetting. And then I can go ahead, add another new subnet. Let's go ahead and use the next next range of address subnet ID here. So let's take this one. We just create 2 subnets. Let's call this subnet B, my subnet B. We put it in US East 1B, that's an availability zone. And then we put /24. We go ahead and create. So it will create for us 2 subnets, right? So these ones will belong to, if you notice, these ones will belong to our test VPC that we created. So that's how you create your subnet. Now, if I go to routes table here, I will see that I don't, my private subnet route table, this is immediately associated to the default VP main route table. So if you create a subnet and you don't create a kind of a custom route table for it, it will take the main route table. But before we come to more of that, let's look into the internet gateway before we come talking more. Since if you have to go to your create a public subnet, you need the internet gateway, which is the next component I wanted to talk about. So the internet gateway is kind of a managed and a regional resilient gateway that is always attached to a VPC. Just keep that in mind. An internet gateway always is always attached to a VPC. And a VPC can only have one internet gateway. You can, or at times you don't attach at all. So that means no traffic is leaving from that VPC to the internet. It runs from within an AWS public zone. It sends traffic between the VPC and the internet or AWS public zone, right? It will always help route table. You can in your route table, you can create default route pointing to the internet gateway. And we mentioned that when you go to, for example, create on your route table, if you create a route pointing to the internet gateway, it makes the subnet in which that route table is associated to a public subnet. So think of an internet gateway as that, from the name, it is that gateway to the internet. When you want resources sitting in your VPC, be the public subnet to reach the internet. And we can go ahead and look into that as well quickly. So if you look again, you'll see that you have internet gateways here. There's already a default internet gateway, but you can create yours. So let's call it my internet test gateway. Right. So that's created. Now we want to attach it to the VPC. So I'll pick my test VPC and I'll attach an internet gateway to it. So that VPC that we originally created now has an internet gateway associated to it, right? And if we look now at the route tables, let's create a route table here called my test route table. We select the VPC this will be used for. It's my test VPC. We create that route table. And you notice on the route table, you always have a default route called local. Destination here is, remember this is the CIDR block we had. So it says for all traffic to this destination, it is local. What this means is any resource created in this network can be able to communicate with others. So if you have an EC2, EC2 1, EC2 2, EC2 3, all of them will automatically talk to one another. This is because of this route here. So it just says that any traffic destined within this IP addresses with this range, they will immediately communicate. But before that happens, if I go now and say I want to edit, you see subnet association. So it has these different subnets. So I can decide and associate that this route table to my subnet A. I will use this one. I want to make my subnet A as the public subnet. So let me associate my subnet A to this route table I created. So it shows now that if I come to subnet associations, I see that this subnet is associated to this route table, right? And the reason why I've chosen this is I want us to edit the routes so that traffic that is sitting on my subnet A, this is going to be our public subnet. We want that, what happens if we want to access the internet, the destination for the internet, or if you are going out of your route table, it's always denoted by 0.0.0.0/0. So what happens if traffic is not going, if you are sitting on your subnet and you want to visit, say, google.com, right? You have something you want to download from the website. So I want that, but I want this to be linked to an internet gateway, and which internet gateway? My test internet, my internet test gateway, the one we created. So if I save the changes now, you'll notice now that there is a route entry for the destination anywhere pointing to the internet gateway. So if I'm sitting now on this subnet now, we have just made subnet A our public subnet. So if I'm sitting in there and I want to reach the internet, traffic will definitely flow, because once it realizes that the traffic is not destined locally, it will use the internet gateway and it will be able to access it. So subnet A becomes our public subnet because it has a route entry to the internet gateway. Subnet B that we have created, it still doesn't have a route tab. It doesn't have an entry. This subnet A, but I wanted to show subnet D. If you look at this route table, it doesn't have any route pointing to the internet gateway because we have not created one. So that's what makes subnet A public and subnet B private. And this is how you can create, you can go ahead and do that on your console. Right. So let's proceed. Yes, go ahead, please.
That connection from 0.0.0.0,
yes,
it to and from, or it's only one way?
For the internet gateway is to and fro, because for the internet, you send your request, it will come back. But we'll see the difference when we come to the NAT gateway. So for the internet gateway, your question is it to and fro? Yes, it is to and fro. So if someone wants to access subnet A that we have made public. So for example, you could have web server sitting on that public subnet. So someone from outside will be able to access that public subnet. Yeah. So it's to and from.
Thank you.
You're welcome. Good. So let's go ahead and talk about network access control list. This is where, and your question could also be linked to that, because then it could depend if you happen to maybe add some restriction. We were just, what we discussed was still more of things at kind of default as we have them. So we've looked at internet gateway. We've talked about what makes a subnet public and another one private. We have shown that on our demo. But now there is what you have. You have this now. Security is always important. What if you want to put some restrictions, right? So this is where network access control lists come into play. And what is a network access control list? It's just basically they are made of, it has allow or deny if you're thinking of specific inbound or outbound traffic, and it works at the subnet level. Very important to remember that network access control lists work at the subnet level. You may decide that for traffic going out, it should maybe access some particular services in the public internet and maybe deny some particular services. So if you don't just want anything to be accessed online, you want to add restrictions, maybe to some particular websites that should be accessed. So you think of using the network access control list at the subnet level so that all resources that sit in that subnet will be able to follow that rule. So it filters traffic at the subnet boundary. When you create a subnet, there's always a default network access control list that is attached to it, right? So I think it's just good. Yeah, go ahead, please.
Sorry, does it mean without the gateway, there's no way? Okay, I think I'm okay. Without that gateway, you can't that network cannot go. I mean, cannot access the internet, right?
Yes, without the internet gateway, you cannot access the internet. If you create a VPC without the internet gateway, the first thing is you cannot access the internet. Without the internet gateway, you cannot access the internet. That's correct. And then the next thing is, if you create a VPC, you create an internet gateway, it does not mean that is the first step is you create the internet gateway. The next step is in your routing table, you must have a route pointing to that internet gateway. If you notice what we did, if I can come back to that, I remember I said that subnet A, which is our public subnet, we say now that resources in this subnet can reach the internet because of this entry here. So this destination, because traffic going to the internet looks at the destination, and this entry is pointing to the internet gateway. So the first thing is, for every VPC, you need to create, and for that you want access to the internet, you need to create an internet gateway. The second step is you must then have a subnet, and then you have, if you look at the route table associated to that subnet, you need to create an entry pointing to that internet gateway. So you need those two steps, yeah, before you access.
All right. Thank you.
Yeah.
Thank you.
Okay, you're welcome. Right. So, but now we were just talking about restrictions that you can now put, because maybe not everyone will want to have everything. You want to put some particular restriction. I wanted to just show that immediately, because that was the next thing in my demo. So again, in your VPC dashboard, remember we went to VPC, you'll find most of the things we are discussing on the left navigation bar. If you come to network access control list, you see that there are different network access control lists here defined, but I want to look into the default one. As I mentioned, For every VPC created, there is a default. Then it's let's look at the VPC, the default VPC here as well. This other one is the one we created. So if you look at it, you'll notice that it allows, when you create when you have a network access control list, you have rules that would define how traffic should be treated when it's coming into the network. You have rules that will define how traffic should be treated when it wants to leave the network. So when you are thinking of network access control list, you always think of traffic coming in and traffic going out. All of that is treated differently. And a default network access control list will always allow all traffic coming in, and then it will always have a final rule at the bottom that just deny. But since rules are always treated in priority, a rule number, this is rule number 100. If I create another rule number 200, rule number 3. So the first thing in access control is you always have rule numbers, and you always start with the one is of high priority, so that's treated first. So when you are looking at a network access control list, you always look at the rule numbers, right? So the only rule number that exists here is the 100, and it allows all traffic, all type of traffic, all protocol, all port ranges from every source. It's allowing that. So the default ACL makes it easy if you are just starting with AWS to just use it immediately without having restrictions. But if you now create an access control list, if you create a network access control list, this one is not a default one. You notice it's default. When you create that, you realize that all traffic is denied. So keep in mind that when you create a new access control list, and if you associate it in a subnet, all traffic to that subnet will be blocked immediately. And that is when you want to do restrictions. And now you are the one to start defining what kind of traffic you want to allow to come into the network and what type of traffic you want to allow out of that subnet, right? So I'm showing this, the key thing I wanted to show was default access control list has a route that allows all traffic in, and also it allows all traffic going out. So you notice I looked at inbound, I look at outbound. If you look at the default, one that is not default created, it doesn't have an allow traffic rule, and it doesn't have also a traffic rule associated to it. And here I can then decide to associate it to a particular subnet. So if I were to edit this and associate to a particular subnet, then restriction will then be given to that subnet. So it works at the subnet level. I'm sure that brings more clarity.
Question?
Yes, go ahead, please.
And I know that you haven't touched on subnet. I forgot, but I was seeing that security groups. But when you get there, please qualify the difference between the network access control list and the groups.
Okay, definitely. Yeah, that's just exactly the next thing we are going to. So your question just came in time. So we have just done the demo for that. The other thing is, remember when I was talking about traffic coming in and traffic going out, that is treated. So network access control list is then referred to as being stateless, right? This is a very important concept to always remember, which means that information about previously sent or received traffic is not saved. So you treat inbound traffic as if it's new traffic and outbound traffic as if it's new traffic. It doesn't know that maybe this incoming traffic or it doesn't know that the outbound traffic could be a response to the incoming traffic you had earlier. So network access control lists are then referred to as being stateless. For that reason, you can associate it to multiple subnets, but each subnet can only have one access control list. There are different components I already showed. This is just for you to refer. I pointed rule number, the type, the protocol, the port range you want to affect, the source, the destination, whether you want to allow or deny, right? This you can receive when you can read into this when you receive the slides. Then we talk about security groups, which is the question that just came in. So security groups acts as a firewall that controls traffic allowed to and from the resources in your virtual private cloud. They are always associated only with resources in the VPC in which you create, right? Security groups are stateful. Remember, NACL is stateless. So for security groups, the key thing is if you send a request from an instance, the response traffic to that particular request is just allowed, regardless of what other rule is sitting in there. So security groups are stateful because they can remember that this request, this response going out is in regards to a particular request that came in earlier on. So this makes security group kind of a bit intelligent. They can know that there's no need to have another rule here to allow this traffic. Unlike the NACL at the subnet level, where you need to always ensure that if you allow traffic coming in, you also need to again allow a response to that traffic for that traffic that is going out. So security groups work on resources. Remember, NACL is at the subnet level. So security groups can be associated, say, to an EC2 instance, but you can associate a NACL to an EC2 instance. Yeah, I don't know if that already answers the question that came up earlier, or there's more clarity needed.
My question is, can't you build a network where you have subnets which does not have the access control list, but maybe you link them to the route tables?
You can, when you create a subnet, and every subnet is always associated to a network control list. So like, for example, when you create a subnet, if you don't associate a network control list to it, it will automatically take the default subnet. So when you create, and I can show that. So when you create, so your question is, so the first answer is, if you create a subnet, right, and you don't associate a network access control list to it, it will immediately take the default network access control list. So a subnet must have a network access control list attached to it. Now, the other question you asked was regarding if you can have your subnet pointing to the internet, right? If you can have a route to it pointing to the internet. Definitely we have, yeah. Was that the question?
I was asking that because I think I have created some days ago, I have created a network, but I didn't touch on the access control list. And it was able to be accessed. So I was thinking, like, if you don't touch on the access control list, then you create the route tables which link your subnet to the internet gateway.
Right? Yeah.
Does that work without to touch on the
network console? Yeah, definitely it works. And that works because if you remember, we created 2 subnets, and I didn't remember, the only subnet we have seen here is the SL2 here, right? But for the 2 subnets that I created earlier on, if you look, you'll see that they are just they have the default subnet associated to it. So I'm here on network access control list, and if I look at this is my test VPC, right? And I have these subnets. You see subnet, this network access control list, which is the default. This one, it has a role automatically attached to it, right? If you look, this role here, this access control list has my subnet B, my subnet A associated to it. It has inbound rule, align all traffic. It has outbound rule, align all traffic. So when you create a subnet, and if you create a subnet and you don't associate any access control list to it, immediately takes the default one. So things will work very well. You won't need to bother, but it comes when you want to start doing restrictions. So a subnet is always associated to a network access control list, and you can then, you either create one or it will automatically take the default role, as you can see with this one here. I hope you can see that difference, right?
So I can see. So the default one comes with the VPC.
Yes, the default one is created. Yeah, it's created immediately. It's always there. Yeah.
All right. Thank you.
You're welcome. Yeah. Right. So if you notice here, default, you see this is network access control list. I have it here. It just says it exists here, default. It takes that. And for this one, this is for the default VPC had 6 subnets, and you see it's also using the default network access control list. But then this access control list that I created manually, it doesn't have. I think maybe to make it better, you do not have any VPCs. What's that? Just okay. Maybe, okay, I think I've been on for more than an hour and I need to sign back. Yeah, that happens. Let me just sign back to my account. I go back here, I come to my management console, and we are back. Okay, so let's go back to our VPC section. I was trying to show this on the network access control list. This is where we are, right? So yeah, as I pointed, I wanted to just create, let me call it my test ACL, right? I say it was used my test VPC. For now, let's just create it, right? So if you notice, my test ACL default is no. So it doesn't use the default, it's not a default access control list. So similar to this one here. But then this one here is automatic. So if I want now to associate, if I want to put more restriction on these 2 subnets, I can then come here and edit and remove these 2 here and associate. So that means the subnets will be blocked because there's no traffic leaving with the access control list. There's no traffic leaving in or out at the moment. But so if I save that, that's what will happen to that. And if you notice, because subnets can only belong to one ACL, the 2 subnets that are here, they immediately come down here. So you cannot have a subnet having 2 ACLs at the same time, right? So I want to remove that because I want to make sure that if we are using that subnet later, we don't have issues. So you see, it goes back to the default one. So I didn't assign this earlier. So there's always that default route that is used immediately. Yeah. Yeah, it's always a very interesting topic, and I hope people.
I also have another question.
Yeah.
Which one takes the precedence? Yeah, like route tables or access control list?
All of them are different, but they can work together. So if you have a route table, right? Okay, if you have a route table, it points to the internet. It allows all traffic. That's the first thing. But then now the question is,
I think he meant the security group and the access control list.
Okay, is that what you meant? Just to be sure that we're answering your question.
No, but
Okay.
you can also add the security group.
Security group. Okay, good. So yeah, that brings up this where maybe we should have graphically always makes it interesting. Let's try to do something graphically since there are questions coming on this. So I assume that this is a VPC, right? Let's look at this as our VPC. The box is our VPC. We have availability zones, right? And remember, with an availability zone here, I'll call this easy, right? And then in this, so this is an availability zone. Let's just say that it has this availability zone, we create a subnet on it, right? So, but before I got there, it has an internet gateway. This VPC has an internet gateway, IGW. We have a subnet here. Let's call it subnet A, right? And now this subnet, remember what I've said that access control list affect the subnet boundary. Now let's assume that we have an EC2 instance here. Remember again that security groups lives at the subnet level. Now, if this is a public subnet, route tables, all of those are different components, but they can work together. So in this subnet, you have a route table, and there's an entry for 0.0.0.0 pointing to the internet gateway, right? So this one points at all traffic. There's a route table pointing to the internet gateway, so it makes this subnet public. But now imagine that you have allowed all traffic to go to the internet, but then on the network access control list, you want that some websites should not be accessed. Maybe you want to block some websites. Then you come to the network access control list and you define a rule that blocks it. So what will happen is when traffic comes and is pointed to the internet, when it wants to leave the subnet will check and realize that this particular traffic shouldn't go. It will then block it. But then traffic that is allowed to pass the subnet, it will then go to the internet. The same as if someone has to access maybe this subnet, and so when I say, let's say this EC2, right? Maybe there's a service here that wants to go to the internet. It looks, there's a route entry because it has the EC2, there's a route entry taken into the internet. So it wants to go. The network access control list looks into it and say, no, you can't go out. It doesn't go. If someone also wants to access from the internet, the traffic is checked at the network access control list at the subnet level. It realizes that this traffic cannot be allowed, it won't come in, or the traffic is blocked. So the internet gateway here, although you have the route entry that allows traffic to go to the internet, but the network access control list is like standing there as the gate to check again, should you really go out, right? Now, the EC2 instance where we can have a security group. So it's at this is what we call in AWS defense in depth. So defense is always at different layers. So at the subnet level, at the access control list here, you can have a rule that doesn't allow outbound traffic, or you can have a rule that allows a particular traffic to go out, but if it goes out, it will reach at the subnet level. The subnet level will still look at it and say, actually, this traffic shouldn't go out, right? Then it will be blocked. So think of defense here is happening in layers, right? You have the network traffic is handled at the subnet level. There's some control, and then there's also some control at the EC2 level. So security is like the inner layer. Think of an onion. You have the inner layer, and the network access control list is like another layer into it. And you'll notice there are different layers of security as we continue to study and go. I don't know if that clarifies that question, or if that answers your question.
Yes. Thanks.
Okay. Yeah, I'm happy if that's helpful, because just note network access control list is at the subnet level. Where we did discuss security groups is working at the EC2 level. So irrespective of how the route table is controlled, the network is still doing its work independent of that, trying to make sure that what is allowed is actually what is intended. Yeah. All right.
Thank you.
Oh,
Thank you.
I'm happy to hear that. Okay. Yeah, so yeah, and the terminology you should think always when you are thinking of network access control is that it's stateless. Remember, we talked about it handles inbound traffic differently, handles outbound traffic differently. Security groups, if there's traffic coming in, if there's a request coming in, it will then know that the response going out should be allowed. It doesn't have another rule in it, right? And in security groups, we can only specify allow rules, but not deny rules. Yeah. This is a summary of the difference between network access controllers and security groups. Security groups operate at the instance level. This is what we were talking about. Network access controllers at the subnet level support only allow rules. This one here has allow rules and deny rules. Is stateful here. Security group is stateless. I'll encourage you to look into this table and really kind of master the differences and also understand what this actually means. And in real life, to bring more clarity, if you are looking at security group example, think of web servers that have to be accessed from the public internet. So they are sitting maybe above here in a public subnet, but then you have database instances that are sitting in a private subnet. And what you need to do is, since these are web servers, they have to be accessed from the public internet, right? So you can create a security group that kind of cover all these web servers, right? So you put all your web servers in a logical group here, your security group, and you create a rule that allows all traffic coming into that web server. But you want your web servers to only talk, you want that your database to only allow traffic from the web servers. Then you create a rule here, you put all your databases in a one security group, and you say that they should only allow traffic coming from the web server. So it protects your database, because database shouldn't be accessed publicly. So that's how you can kind of create, use security groups in real life here, using putting them once. Yeah, go ahead.
But isn't traffic inside the VPC allowed from every resource?
From every resource.
Yeah.
So, right. Yeah, definitely it's allowed. I'm trying to, like, you have your VPC, right? So there's a rule that it allows them to communicate, but you can then define a security group, right? I think that question is still coming from routing. Traffic is allowed, but you use security groups and network access control lists to still control, again, what is allowed. So even though you have routing just says that this communication can happen, security groups say that this is what is actually allowed to happen.
Oh,
does that help? Yeah.
yes.
So although all these resources have a routing entry for them to talk, but then security groups is actually telling what is allowed. Yeah, so that's the difference. Yeah. Hope that helps. Yeah. Yeah. Okay. So this is what can happen here. You can decide that for your security group, for your web servers here, they are able to take in traffic coming from the internet. But then for the database servers, the traffic that is actually allowed to reach the database is from the web servers. Right. So the difference here is when you're talking about the routing, you don't need to go and configure routing that, okay, this host should talk to this host. That is already automatically from that local route entry we saw in the table. That communication is already existing, but now you use the security to decide what should be allowed to happen in here. And I really understand, especially the questions you all are asking, because always knowing which component you have to look at routing entry differently, look at security group and network access control list differently. But all of these things, they work together to help you do some kind of fine control on the things you want to be happening. So this was just an example here. Remember, I've not put the network access control list. So maybe there could be another network control list that sits to again define if you want more fine control on how traffic, what kind of traffic. Like I said, maybe on your web servers or for traffic going out, you don't want some particular internet sites to be accessed. Then you can decide to put all of that at the access control, network access control list. But I don't have that shown here. I was more focused on the security groups. Yeah. Okay. Then let's look at another component called VPC flow logs. So you have all of these things happening. How do you want to maybe figure out, capture for certain reasons, maybe analysis purposes, you want to capture the information going and in of the different network interfaces you have. So that's where VPC flow logs come in. It's a feature that enables you to capture information about IP traffic going to and from your network interfaces in your VPC. So it's looking into your VPC. The flow log, the data captured can be published on CloudWatch logs, Amazon S3, or maybe Amazon Kinesis Data Firehose. You'll see that as you go along, one of the services. So when you create a flow log, you can then retrieve and view the log records in a, for depending on what you want to do with it. So you may want to do some kind of diagnosing overflow restrictive rules. So maybe you have created these rules now and you expect that your traffic should be working in a particular way, but it's not working. You want to figure out which rule have I created that maybe is over restricting the flow of data. So if you create your security groups and you think they should be working in a particular way, but you realize that they are not really giving you that, you can look at the flow logs and you'll be able to see where traffic is dropped, where traffic is allowed. You can use that for monitoring the traffic that is reaching your instances, determine the direction of the traffic to and from your network interfaces. So you can put the VPC flow log either on your subnet or subnet or VPC, or you can even put it on the network interface to monitor just your network interface. So that is where you can really have your VPC flow logs. But the key thing is you want to do some diagnosing regarding the groups you have created. You want to monitor traffic. You want to look at the direction of flow. So this is something, an example that you can have. So you do VPC flow log here. You can create VPC again at the subnet or network interface, and you can create that the traffic to be, say, deposited on an S3 bucket, and then you can look into it later. Yeah. So think of, if you want to do some diagnosis on or monitor your traffic, this is where you go. We have done demos on security groups. Let's just do some quick knowledge check to make sure that everyone is active. So one makes a subnet public and another one private. Anyone just want to just say that? Let's hear.
Yes. In a subnet, in a public subnet, the public IP is automatically created, while in private, it's not.
Right, that is also true. Yeah, you definitely need that. But what else also make that subnet? There's also another key aspect. So public subnet, they'll have public IP. Yeah, go ahead.
So I believe a public subnet should be reachable by anyone, and private cannot be reached by everyone unless you are in the subnet. So I want to believe that what makes public is because the ACL it has allows all inbound traffic, and private denies inbound traffic. And that's what I think.
Okay. That you have talking in the point of that's where you are doing fine control. But what happens if you didn't use network access control list? There's also another feature. So imagine you don't have network access control lists at this point. What will make it public? Let me just go back. We did touch on that. If you remember, let me just go, we see that. And that's just important to remember. I said that for public subnet, it has a direct route to an internet gateway, right? So when you think of public subnet, always think of the internet gateway. Relate the public subnet to the internet gateway. And I made one of our subnet public. I did call, where is my screen here, right? If you look at the subnets here, let's look into that. I did call subnet B public. No, not subnet A. I did call subnet A public because if I look in the routing table, there is a route entry that's pointing to the internet gateway. So that's what makes a subnet public. The other one, the one you mentioned on the network access control list, the key thing is that that is when you are now putting restrictions. But what happens if you are not putting restrictions, right? So the first thing is that there should always be a route entry pointing to the internet gateway. I did like the first also response we had. Yes, definitely. I didn't mention that all resources created in the public subnet definitely have public IP addresses because they will need to communicate using those IP addresses, right? But the key thing is subnet A here is public because it has this route entry. Subnet B is not public because it doesn't have a route entry pointing to the internet. It has a route entry that only exists locally. So that's what will make a route, that will make a subnet public and the other one private. Thank you. Yeah, that's good. So how many internet gateways can you attach to a VPC? Anyone remembers? Only one, right? For every VPC, you can only attach one internet gateway. Just keep that in mind. You can't have two, so only one internet gateway, right? So key takeaway again, remember VPC router exists in every VPC, but you control that router through route tables. You will never come to a point where you need to do anything with the VPC router. I mean, most of the time you can go through your course, you'll never even be talking about VPC router, but route tables are very essential when you want to define how packets should leave your subnet. A subnet can only be attached to one route table. A route table can be attached to many subnets. Knuckles are stateful. I hope you remember what stateful is. We did discuss that. If not, please come back to that. So inbound traffic is treated differently. Outbound traffic is treated differently. Security groups are stateless. It has some intelligence. It knows that this traffic came in. So if the response is going out, it will automatically allow it. Very important components there.
To try to contact Daniel. Can you tell me his number again?
Okay.
I lost my. I was Wi-Fi again. I lost my SIM.
Daniel number.
Okay. I think that's not a question. Maybe James can mute himself. Okay.
He said you want to do it before he goes.
Sorry, James, can you mute yourself so that okay, thanks. Right. Now we just talked about, remember we are in that example I showed under security groups, we had databases sitting in a private subnet. If you want your databases, you can always protect them by having them in your private subnet. But what happens if those databases need you want to do updates, right? They need to go online and get some traffic. That's where NAT gateways come into play. And a NAT gateway is just a network address translation is a service managed by AWS. It's highly available. And what it does is you can use NAT gateway so that instances in your private subnet can connect to services outside your VPC. Yeah, hello, go ahead.
Yeah, sorry for cutting you short. I think on that key takeaways, I think there is a mix-up. ACL are stateful or stateless. I think what you said before is stateless. Yeah.
Thank you. Absolutely. Thanks for catching that. I'm glad you saw that. Thank you. You are definitely attentive, Hilary. Yeah, that should be stateless and stateful. Thank you for that. I'll correct that before I send the slides out. Yeah.
All right. Yeah.
Thank you. Thank you very much. Yeah. Yeah. Thank you very much. Okay. So we are talking about NAT gateways, right? So NAT gateways was that just network address translation, and it enables instances in your private subnet to connect to services outside your VPC, but external services cannot initiate a connection, and this is very important. External services cannot initiate a connection, and also NAT gateways are always placed in the public subnet. So these are two things I want you to remember very well about NAT gateways. They help instances in the private subnet to reach the internet, but external services cannot initiate a connection to those instances. And the third one is NAT gateways are placed in the public subnet. This will be better if we look at it on a diagram. So you have a public subnet here. We have a NAT gateway. Then we have an instance here, say database instance, and maybe this database instance needs updates from the internet. So what will happen is it will initiate a connection, and then what will happen, we'll see this very shortly. So in this, you have private subnet, right? You define on the routing table associated with this private subnet, you will define a route entry that points to the NAT gateway. So what will happen is when traffic wants to leave, we will realize that if I want to go to the internet, there's a route entry pointed to the NAT gateway. We'll come to the NAT gateway, and then it is able to go to the internet and get downloads. But the other point is you cannot from the internet try to access the database. That will not be allowed. That's what it means by the NAT gateway only allow connections that are going out, but you cannot initiate connection from outside. So the connection that comes from outside is always the response traffic. Communication is always two-way, request and response. So in this instance, we do a request to the internet, the response can flow back, that's not a problem, but you cannot have a request coming in and expecting a response will go out. So no requests are allowed. That's what it means by you can't initiate connection from outside to the instance. Yeah.
I also have a question.
Yes, just a moment. Let
All
me.
All right.
Okay, good. Go ahead. What's your question?
Yeah, I've seen that on the internet gateway and on that gateway, they mentioned that those resources are highly available. And
Yes.
I want to know what does that mean?
Okay, good question. Yeah, highly available means you AWS manage these resources, and what it actually means, if something was to happen to it, they will be immediately taken care of in the background. You won't be so highly available here means in terms of availability. If there's something happening in the internet gateway, they can maybe a new resource is spun up immediately that can replace that resource. Yeah. So they're highly available. So if you have if something was to happen, let's say there was a failure on this instance, you won't notice it. Another resource will replace it immediately, right? Same as the NAT gateway. So they are highly, it's just mean high availability. You don't have to be bothered that what happens if the internet gateway fails. Yeah, something will be replaced or looked into immediately. Yeah.
Right.
Okay, good. So let's just look into how does that work, right? Because we have just mentioned this, but how does that work? So this is how the mapping happens. So the NAT gateways, we map the source private IPv4 address. Remember that we have a database here and it's a private one. So it will map the private IP address to the private IP address of the NAT gateway. And then the internet gateway will then maps the private address of the NAT gateway to the elastic IP associated to the NAT gateway. So every NAT gateway has an elastic IP. Elastic IP is more of a static public IP address. So elastic IP is a static public IP address. So that means it's fixed, right? It doesn't change. It's always associated to a NAT gateway. So the internet gateway will map the private IP address of the NAT gateway to the elastic IP address associated to it. And then when that is generally how this goes. So because it now has a public, the elastic IP, which is static and which is also public, is then able to go to the internet. So the NAT gateway has, the NAT gateway is sitting in the public subnet. And since there's an entry that points to the internet gateway, is then able to go to the internet. And when response traffic is coming back, the NAT gateway will translate the address back to the original source IP address of the instance and send it back to it. Yeah. So that's just generally how it works. You don't really need to get into the, I'm just putting this here for you to have an idea. But the key thing that you can do that's important, which is this entry I've just shown here. When you create a NAT gateway, if you want a subnet to be able to use the NAT gateway, you need to go to the root table associated to that subnet and create an entry that points to the NAT gateway. You can remember earlier on, we create an entry that did point to the internet gateway. So you instead go to the private, to the root entry for your private subnet and create a root entry that will point but to the NAT gateway. And that's why we have it this way. So this is a private subnet. We create a route table in the entry of the private subnet. The private subnet, it has a route table. You point an entry that shows it should to the NAT gateway, and then traffic, when it's sent to go out, you will realize that, okay, it's not local traffic, but that traffic should go to the NAT gateway. When it reaches the NAT gateway, it has it sits in the public subnet, and that public subnet has an entry that points to the internet gateway, and then it will go out to the public. So that's how the NAT gateway really functions. You need to create an entry in the private subnet table pointing to the NAT gateway for you to be able to go out, get traffic. Let's say you have databases that needs to get updates and then have that back. I hope the concept of NAT gateway is clearly understood. So NAT gateway has a complete different functionality for internet gateway. NAT gateways is when you want instances in your private subnet to reach the internet, but the public, the internet gateway is always just sitting there for enabling instances in the public subnet to always reach the internet. So that's how you enable instances in the NAT, in your private subnet to reach the internet through the NAT gateway. But most importantly, traffic cannot come from the internet to your instances. It cannot be initiated, so you can send requests, but only response for traffic that was initially sent out can be taken in.
Yeah, question, but also the NAT gateway goes through the internet gateway to reach out to the internet.
Yes, because it sits in the public subnet. If you notice in this diagram, the NAT gateway sits in the public subnet. So there's a route. Since it sits here, there's a traffic, there's a default route in the public subnet pointing to the internet gateway. So yeah.
Yes.
Good. Right. So a lot about components there. That's just basically all we have touched in. We can look now into other aspects of networking, and which comes now to VPN. We're trying to look now, when you create your resources on the VPC, AWS cloud, what happens if you still have a data center or you have an on-premises location? How do you link that together, right? So that is where we are moving into now. And here we'll be talking about VPN and direct connect. But before we move to that, let's just quickly define what is actually virtual private networks. What is actually VPN? So a VPN actually creates a safe and encrypted connection. Take note of the word encrypted connection over a less secure network, such as the internet. We know how the internet is very secure. And then traffic that is this encrypted traffic will pass kind of like in tunnels and is protected from internet traffic, and you'll be able to have kind of a secure connection running through a less secure, a secure tunnel running through a less secure network like the internet. So encryption basically means you kind of scramble information in such a way that it cannot be read. So you take data and you kind of have it scrambled in ways that it's no one can be, even if you intercept it, you won't make sense of it. So VPN again is just having encrypted connection over less secure networks, and an example here is the internet. And encryption is the process of scrambling information so that it's not easily understood, even if it's intercepted. Now, why will you need VPNs, and that's why AWS created the AWS site-to-site VPN here. The issue is you have created your instances in Amazon VPC, but they can't communicate to your remote network, say your data center. What you then do is you can enable access to your remote network by creating a site-to-site connection and configuring routing to pass traffic through that connection. And we are going to touch on the different concepts that can enable that. So just be patient. And before we do that, we have to define some key terminologies. You always hear what is referred to as a virtual private gateway. A virtual private gateway is actually a VPN endpoint that you have on your VPC site, so the Amazon site. So you can always create a virtual private gateway. It's similar to the concept of the internet gateway that we had, but it's different. It functions differently. So think of a virtual private gateway. It sits at the VPC end. You have a customer gateway device. This can be, for example, a router. This is a physical router that you can be familiar with. So in traditional data centers, you always have a customer gateway, right? This sits on the remote location. And then when you have these two, you can then be able to create a VPN connection, which will always be between your on-premises equipment and your VPCs. So this is how it will look like in a diagram. So think of an on-premises network. You have your data center here. This could be an office location. Then you have the VPC. You have choose a particular region. You have a VPC created in there. As I mentioned, the first thing is you create a virtual private gateway, right? This is a concept similar to the internet gateway, but this is used for site-to-site VPN. So you have this one here. You have the customer gateway. Then now you're able to then create a VPN connection, and this will be using the internet, right? So this becomes a secure connection because this is like a tunnel. You have traffic that is passing through it, but since it's encrypted, no one can be able to have access. Yeah, your hand is up, Hilary. Go ahead, please.
Okay, thank you. Yeah, I wanted to ask this before we leave that part. How many subnets? I understand you mentioned 5 VPCs in a region. So
Yeah.
the subnets are on the zone level. So how many subnets in a as in the maximum number of subnets we can have in an availability zone?
It will depend on the CIDR block you are using, right? Remember that for each VPC, you can subnet it,
okay.
right? Yeah,
Okay.
you remember that, right?
Yes.
Yeah,
yes.
Okay.
So it's IP dependent, the number of hosts available, right?
The number of subnets you can create, actually, yeah. Remember that number is dependent on that you can get. And AWS have a certain maximum. You have the /16. That's the maximum block you can use, and then the minimum is /28. So if you think of those numbers, then depending on how many subnets you can create, if you look at I'll share the subnet calculator. I don't know how many people are familiar with that, but depending on that, it will always help you. I think I have it here, right? So if you look, for example, this one has number of subnets is 256. So if I go, the minimum you can have is AWS here /28. So the minimum here is 16 subnets, and the maximum is /16, you see. So this is 65536. If you want to, in this case, yeah, you have /16. Yeah, so this is like the maximum number of subnets you can have.
Okay, thank you.
Yeah, so it's dependent on those values. You are welcome. Yeah. Olivier, just remind me, how much time do we have again? When are we supposed to stop for more questions? If you can help me that.
We still have some time. Maybe in 20 minutes.
Okay.
How long? Because we also usually do a quiz afterwards. But
right.
yeah, we'll go through it until what you prepared is done, and then we can do the quiz, and we'll do the feedback as well.
Yeah. Definitely, I have some. I think we are we're in the area where if the concepts that we've covered so far are good, we'll definitely move a bit fast here. But I appreciate the questions that are coming in. The key thing is for more clarity, because once you have the foundational concepts, once you are good in it, the other things, you will realize that you will quickly move on. Yeah. So the key definition when you are talking about AWS site-to-site VPN, this is what I would put as a takeaway. Always remember, on the AWS side, you need a virtual private gateway. On your host, on your on-premises network, your local data center, or your office premises, you need a customer gateway, which is like a physical router. Then you can then create VPN connection and then do routing, configure routing that will be pointing that traffic maybe that is supposed to come to this particular network should use this VPN connection. And on your virtual private gateway, you configure routing saying that traffic that is destined for your network here, you have it should pass through this VPN connection. That's how you connect your on-premises to your VPC. But take note that the maximum throughput when you are using VPN is 1.25 gigabits per second, right? And this is very small for some people. So the question is, what if I need 10 gigabytes per second? So VPN is good. It's very quick to set up. You configure it. If you want to set that up, depending if you have all the information, 2-3 hours, you can have that running. Your on-premises network is communicating to your VPC, right? But as I say, you have 1.25 gigabits. And remember, again, you are using the internet. So what happens if the internet is not there? Your connection won't be available. But now, the question is, if you need more speed, if you need much more reliable connection, this is where direct connect comes in. So direct connect is another method of connecting your remote location to your VPCs. And here you are actually establishing a physical and a dedicated connection between on-premises and AWS. So you really have a physical connection. You have a network that is created that runs from your on-premises and meets the AWS network as well. So the connection is private, it's secure, it's fast, it goes through that private network, but take note that it takes at least a month to establish, because as I say, it's a physical connection. And this is always important in questions as well. You may always have a question that is trying to see if you understand the amount of time. If you want to establish a connection between your on-premises and the VPC and you need a day to do that, you can't think of a direct connection because you need more time for it to be created. And one thing about direct connect is that you come to learn about public virtual interfaces. The public virtual interface that will enable access to AWS public services like Amazon S3, but then the private virtual interface enables connection to your VPC. It's better looking at that in a diagram. Let's look at this completely. So we have on-premises here. We have your AWS network here. You're in a particular region. Then you want to create a direct connect. So actually, there's always this is like a building, right? Where AWS routers are sitting. Remember, AWS network is actually a physical network that spans the whole world globally. So you actually have a building where you have AWS. This is on the right here. You have AWS routers sitting, and then maybe you as a customer, both of you, the AWS, you have a router also sitting in that same building, and then there's a connection, a physical connection linking your own router to AWS router. Not everyone has that possibility to have their routers sitting in AWS, so working with different providers, network providers, which are referred to them as partner providers, they will help to connect your on-premises to AWS network. And these partner providers have their routers sitting in the same location where you have AWS routers as well. So you have that physical connection. And as I mentioned, the private virtual interfaces will help you connect to your VPCs. And the public virtual interfaces will help you connect to, say, Amazon S3. It's important to know the difference between these two. Public AWS public services like S3, private, you have VPC, and you have a real building where all of this is happening. I hope that's clear how the difference here, but it takes a month to establish this because of the time. It's a physical connection. So dedicated direct connect comes with different speeds, 1 gigabyte, 10 gigabytes, 100 gigabyte ports are available. So this is for high speed usage. There are also what is referred to as hosted connections, 50 megabytes, 100 megabytes. For the practitioner and especially starting this, how this is done, hosted connections and dedicated connections is a whole material depth. You can go into depth, but the key point takeaway is if you need more speeds than 1.25 gigabyte, remember again, if you have a question and you are looking for 5 gigabits and you want to connect on premises to your virtual private cloud, and they are talking of 5 gigabytes, you know immediately that VPN cannot deliver because the maximum is 1.25. So you can then start thinking of dedicated connections. Yeah, but you can use both of them in a real setting, and they can be helpful for you. So what happens? You have on premises, you have done a direct connection to your VPC. Remember, this is physical. What happens if someone, and it always happens, there's some construction work going, and maybe this cable is damaged, right? And there's no, the only connection, the physical cable that really maybe between the on premises and the direct connection, that co-location facility I was showing earlier on. So this is always referred to as a co-location, which is a building here. What happens if this is physically damaged? Then that's why the backup is important. So what normally happens is most customers will create a VPN, a site-to-site VPN to their on-premises, but also have direct connect. So while they are using direct connect, if something happens, then the VPN functions as a backup. So both of them can be very helpful. Then you configure routing in such a way that traffic is always using the main direct, but if something happens here, it will be using public. So you can be using the site-to-site VPN while then you are waiting to troubleshoot and fix this. Yeah, hope that helps. So we have touched on how to connect on premises to your VPCs. We have talked on site-to-site VPN. We have talked on direct connect. Let's look at what about connecting your VPCs. What happens if you have VPC A and VPC B? Remember, all of them have there are different networks on their own. They are virtual data centers that sit independently. If you want to connect them, what do you use? That's where VPC peering and AWS Transit Gateway come into play. And VPC peering is a connection. Peering connection is a network connection between two VPCs that enables you to route traffic between them using their private IP addresses or the IPv6 addresses that you have into it. Think of it this way. Imagine a customer A, he has resources, he has an AWS account with VPC, and you have customer B with resources also online. And it happens that customer A buys customer B, right? So there's a business that happens to buy a major business, and there's a merge between these two companies, right? So now it happens now that the resources that are sitting in B, they need to talk. Then this is where VPC peering can be useful. Although there are some kind of recommendations, there are kind of things that have to be made before you can connect those VPCs. But that is where bringing two VPCs together can be useful. If a certain company decides to buy, say, a smaller company and they have VPCs and you need those VPCs to talk, that can then be useful. The first thing about VPC peering is that the CIDR blocks should not be overlapping. What does that mean? We talked about overlapping IPs earlier on. That means the addresses in VPC A shouldn't belong. So you cannot have this two VPCs with the same CIDR block and connect them. Remember, it will bring confusion because you have addresses, you have So you like have host with same address in another VPC and you want to combine both of them. So the key thing is the addresses should not be overlapping. The CIDR blocks should not be overlapping. And then it's also what is referred to as transitive peering doesn't exist. I will show what that means shortly. So if you have VPC A and VPC B, as well as C, just because you have paired VPC A to B and then B to C, it does not mean automatically that A and C can communicate. So let's look at this in the diagram. You have VPC A here, you have VPC B. The first thing for this peering to happen is the CIDR blocks here should not be overlapping, right? So then you can then pair this. This one also, the CIDR blocks should not be overlapping. This can then be paired, but because A is to be paired with B and A pairs with C does not mean now that instances in B can talk to C. You have to create a separate connection to it. That's what's meant by VPC peering is not transitive, right? So it's a very good point to always remember the aspect of overlapping and also that VPC peering is not transitive. Those are some key things you should always have in mind. Right. Now, VPC peering has a disadvantage in that when you start having tens of thousands of VPCs, imagine we are just looking at 3 VPCs. So if I want this to communicate, I'll create another peering connection. If I have another one here, it starts getting too crowded, right? So it runs out of control. I mentioned this already. Let me just move to the next slide here. What I mean is, if you have VPC peering, it's difficult to manage. It makes the network so crowded. Like you have 4 VPCs here. You are doing all these peering connections. It's difficult for anyone, maybe any administrator, say network engineer, trying to ensure that this is just 4. Imagine you are having 10, you are having 20. It's really, really, it can get out of control and difficult to manage. That's where transitive gateways come in. So transitive gateways are regional resources, but they can connect thousands of VPCs within the same AWS region. Think of a transit gateway as a hub. I always want to look at a transit gateway as a roundabout. Just imagine a roundabout with different exit routes coming into it. So you come into that transit gateway, you come into that roundabout, then you pick out where you want to exit, right? So it's that roundabout that every entry comes, you pick out depending on which direction you want to go, you go out. So if you look into it in this diagram, it's much more clearer. So you have VPCs here. And then if you were thinking of this as a roundabout, so if you wanted to come to this direction, you get in here, then you exit here, you get in here, you exit here, depending on where you want to go. And if you can add more VPCs as you want, it will then have routing entries that is pointing, you pick the exit location that you want to go into. So transit gateway actually helps simplify when you are thinking of doing connections. And the other positive thing about transit gateway is you can also use them to create via site-to-site connections to your on-premises network. You can also use to put on any third virtual appliances that maybe needs to be connected to other branches as well. So transit gateway is a hub that gives you possibility to do, simplifies the way you can do peering, simplifies the way you can connect to on-premises. And then there's also the part of where you can also pair transit gateway to other transit gateway, making you build more complex networks, but in a simplified manner. Yeah. Any question on this? So think of transit gateway as evolution of doing things better when you are connecting VPCs, or also when you want to reach out to your connections here, online. So this is just more literature, nothing special. I've touched on that. Key takeaway is transit gateway is a regional resource, can connect thousands of VPCs within the same AWS region. Of course, you can do VPC peering on 1,000 VPCs, but you can imagine what that will entail, the kind of work you have to do. So Transit Gateway simplify that. It's a transit hub that you can use to interconnect with virtual clouds and also on premises. It enables customers to connect thousands of VPC. You can attach to all hybrid connectivity VPN to a single transit gateway. So we have talked on that. Let's look at another concept called VPC endpoints. We're slowly coming to the end. And before I touch that, I want to point this diagram because at times when you people think of AWS network, they at times just feel like it's already in the internet, but you have different zones, right? You have the AWS cloud, which is a network on its own. Then you have the internet, which is where all internet services sit. But then even in AWS, you have what is referred to as a public zone, and there are some services that exist in the public zone, like S3 sits there, DynamoDB sits in the public zone, SNS, some services that are referred to as public services, they sit in the AWS public zone. Then you have VPC sits in the private zone, right? And in order to reach the public zone here, you always have to go through the internet gateway, as we already demonstrated using VPC earlier. You have to always go to the internet gateway to go either to the public, if you want to, by default, to leave the private zone and come out here, you always use the internet gateway so far as we have looked into. So this is how they always have this setup in mind. The internet, the AWS cloud is not sitting in the internet. It's a private network out there. It has a public zone. It has a private zone. Where VPC lives in the private zone, there are some public services in the AWS cloud. The worry is, if you look into, let's concentrate on this zone, on this particular area. This is all AWS network. It has a public and a private zone. Definitely things can be done better. If I'm sitting here and I want to access resources here, why should I go through the internet gateway? That's where VPC endpoints come into play. And VPC endpoints enable customers to privately connect to AWS services that are sitting in the AWS public zone using what is called VPC endpoints. And when you are using VPC endpoints, your instances no longer require public IP addresses to reach those resources. And the traffic between your VPC and the service don't necessarily have to leave the AWS network. So this is how it looks now. If I'm using VPC endpoints, this AWS network, now instead of going through the internet to reach S3, for example, instead of going through the internet gateway to reach Amazon S3, AWS gives the possibility of having VPC endpoint here that resources in my VPC can be able to access S3, right? And as we'll see, there are different types of endpoints. I already highlighted them. You have VPC endpoint, you have interface endpoint. We are going to just touch on them differently. But the key thing is these endpoints help you, traffic stays inside AWS network and you don't need to go, you don't need to use the internet gateway. So, and then the resources here have the private IP. So let's start with interface endpoints. So an interface endpoint is just a collection of one or more elastic network interfaces with private IPs, and they serve as an entry point for traffic destined to particular supported services. SNS, for example, CloudWatch, all of them, they support interface endpoint. I think it's as of February, Amazon S3 didn't support interface endpoints before, but February 2021, I think it's available on AWS network. It's now support as well interface endpoints. So interface endpoints are actually elastic interfaces with private IPs that serve as an entry point. So you see there's an interface endpoint here. This is, for example, SNS. You can then access without going through the internet. Gateway endpoints are the second type of endpoints. and they provide reliable connectivity to Amazon S3 and DynamoDB. These are the only two AWS services that support gateway endpoints. Take note of that. Amazon S3 and DynamoDB, right? They do not use AWS private link. And as I mentioned, these are the only services that will support that. So that's just, there's more into this, but at this level, just knowing that to access the public services in AWS, rather than using the internet gateway, you can use interface endpoint and VPC endpoints, and DynamoDB and Amazon S3 support VPC endpoint, and all other services that use endpoints will support interface endpoint. Yeah. And I've touched the services examples here that will support interface endpoint. Okay. A gateway load balancer endpoint is also an elastic interface endpoint with private IP addresses from your private reach. And these are mostly used when you want to intercept traffic, and maybe that you have and send into this and send to load balancers for security inspection. This will come when we look more into load balancers, but I just wanted to bring it here because it talks about endpoint. Let's talk about that later. But before going there, let's touch on some other services when you're talking about networking, like Amazon Route 53. But before that, what is DNS actually? Because Route 53 is the DNS service in AWS. DNS stands for Domain Name System, and it's just trying to always translate domain names into machine-readable format IP addresses. We know that hosts communicate using IP addresses, but when you have a domain like www.example.com, it can be able to translate it to an IP address 1, 2, 3, 4. So that's what domain DNS actually is doing. And Route 53 is Amazon DNS service. It's also highly available, it's scalable, uses port 53, and it's in charge of doing those translation, right? When you talk of DNS, there's always the concept of hosted zones. And this is just a container that will hold information on how you want traffic for a particular domain to be routed. You have public hosted zone that determines how traffic is routed on the internet and be created when you register your domain. So when you want to register, you can register a particular domain in AWS using Route 53. And you can decide to make that domain a public hosted zone. And a hosted zone is then that container that will make you define how you want things to move or how you want traffic to be routed. You have private hosted zone, which is for your Amazon VPCs, and you determine how traffic is routed within your VPC, and if resources should be accessible from outside the VPC. So you can define that. So Route 53 comes with hosted zones, as we've just pointed here. You'll learn that there are different resource types. You have A records, which are meant for IPv4 addresses. You have 4A meant for IPv6. These are some of the type of record types that you can look into, but just putting this for information. DNS is also a very big topic on its own, but just wanted to point these different resource types that we have. Then in Route 53, you also have routing policies, which is also, there are different type of them. You have simple routing policy, failover routing policy, latency routing policy that you can also look into. This is mainly, the simple routing policy is the default one. And this is, you create them when you create your resource, and you must choose a routing policy that will be applied to it. So when you create a particular resource record, you will decide whether you should use a particular routing policy. And from the names, you can see failover routing policy. We want to configure active passive failover so that if in case the active one fails, the passive one can take over. Latency, when you have resources in multiple AWS regions and you want to route traffic to the region that provides the best latency. Yeah. There's a link to see more of this, but this is also just for information purposes, at least to know what's back behind Route 53. But knowing that in AWS, the DNS service is Route 53 is important. Knowing that it uses port 53, and knowing that, of course, it has some routing policies. It's helpful. Let's just look briefly at the Service Cloud front. But before we got there, one thing I always like to think about is, where did this come from, or what really did drive this? And Route 53 is a content delivery network. But the question is then, what is a content delivery network? A content delivery network, or CDN, that is, as it's mostly referred to, is just a geographically distributed of servers that work together to ensure faster delivery of internet content. That's the key thing. Geographically distributed servers that are working together to ensure fast delivery of internet content. We live in a world today where there's a high interest in content, and so there's a high need. So CDNs play a very big role to do that. We think of Facebook, Netflix, Amazon, they all use CDNs, and you can think of it in this manner. So if you don't have a CDN, think of, let's say there's a server sitting down here with the song Calm Down by Rema, and you want to, and there are people around the world, it's a hit that everyone wants to listen to it. If you just have it in this server, everyone will try, be in Australia, maybe India, Europe, North America, they all want to access it from here. You can immediately just start thinking of the latency, because the farther you are away from the server, the more difficult time it takes for you to have your song to upload. And we are very impatient world of today, where we want to click and things just happen. So this is where the CDN come into help. So with the CDN now, you have these geographically distributed servers, and what happens is they are caching this so the original song will be here, but these CDNs are acting as cache. That means they are keeping a copy of the song, right? So when someone is sitting, say, in Europe, when they want to listen to this song, when they want to access it, they'll first check the server, the CDN server that is beside them. And if they don't get the song in here, then it will be requested from the original server. And when the original server gets it to the CDN, a copy is kept here, and the reply is sent to Barry, for example, who originally requested from it. What happens now is, if another user now wants that particular song and he's beside the server, the CDN server here in Europe, when he checks the CDN, the song will already be there. It's cached. The person will just use it. So we don't need to come down here. And that happens to all the different servers that are located around the world. So they are caching the song so that helping into faster delivery. So CDNs help improve load times, they reduce bandwidth costs. Those are the key concepts. And CloudFront is then the AWS content delivery network that we're talking about. So it's not, if you know what CDN is, as we have described, that is exactly what CloudFront is doing. It has, it's a fast content delivery network service that securely delivers data, videos, applications, and APIs to customers globally, with low latency, high transfer speed, and of course, in a developer-friendly environment. It brings also some security capabilities that you will learn as you continue in your journey in the cloud. Maybe understanding what field level encryption is. It supports HTTPS, it uses AWS Shield, AWS Web Application Firewall. Just know that CloudFront brings in advanced security capabilities. But the key thing there is a CDN. Yeah. This service before the last one is just the Global Accelerator, which is mainly similar to CloudFront, but it's a networking service that helps you improve the availability, performance, and security of your public applications. The key thing is Global Accelerator always provides two global static public IPs that will act as a fixed entry point to your applications, to your application endpoints. like load balancers. So if you have your load balancers in AWS and you want a fixed entry point to them, you can think of Global Accelerator. No, they are separate services, but they use the AWS Global Accelerator and Amazon CloudFront are actually separate services, but they use the AWS Global Network and its edge locations around the world to easily deliver content, right? And most better seen in the diagram. So imagine if you have a region here, you have, let's say, a load balancer sitting in this region, and you have someone here who wants to access that load balancer. In the situation where you don't have Global Accelerator, what will happen is that that traffic will first of all pass through it will go through your local internet service provider, go through different networks before it finally reaches AWS region that you really need. So it can take many networks to reach the application. Paths to and from the application may differ, and each hop impacts performance. But when you have AWS Global Accelerator, what happens is it will use the edge locations and immediately bring the closest edge location so that you quickly enter to the AWS network. And once you are in the AWS network, that traffic is then routed immediately to the AWS region. So you can see that with the Global Accelerator, there's definitely a much more higher performance here. So it brings more efficiency and of course, improved performance. Yeah. Any question on Global Accelerator and CloudFront? I think I just touched them a bit fast there, but I think with the literature, anyone looking at it can understand. Assuming that, but just to make sure that it's not a heavy assumption. Hilary, are we good? Don't say I'm picking on you. What about you, James? Definitely. Go ahead. I can't hear you.
Yes, can you hear me now?
Yes, Hilary, I can hear you.
Yes, at some point I had to attend to something, but while going through the slides, if I have a question, I'll reach out.
Okay, good. That was
But
fine.
from where I joined, I am fine. Thank you.
Okay, thank you for confirming that. Yeah. Right. So yeah, if I'm in the group, so if there are any questions, I'll always be available to answer. So that's CloudFront and CDN, but you can't talk about networking. The last service for today is the Elastic Load Balancer briefly. What it is, load balancers are just servers that forward internet traffic to multiple servers downstream. So if you could think of these different colors representing different users, user 1, user 2, user 3, they make requests to a load balancer. The load balancer distribute that traffic to different instances here. So it's just accepting requests and then kind of forwarding it to different instances downstream, as you can see here, right? And why should you use load balancers? They are highly available. They are scalable as well, fault tolerant. Highly available is they automatically dictates unhealthy instances and routes traffic to healthy ones. Scalable means that if the traffic load is getting very high, so instead of 3 people, you have 3 people, as I showed in the diagram, 3 different requests coming in. What happens if you have 100 requests? So the Elastic Load Balancer will be able to scale and handle those varying levels of traffic. They are fault tolerant, means that traffic across multiple availability zones to ensure application remains available even if one AZ experiences an outage. So fault tolerant is more of in a regional setting because Elastic Load Balancers are regional services. So if the whole region was to go down, then the Elastic Load Balancer will also go down with that. But if it is just in the region, if you are thinking of availability zones, Elastic Load Balancer is fault tolerant in terms of AZs, right? So that's why you should be using, the other thing is easily set up. In AWS, you can easily set up an Elastic Load Balancers. In some cases, it offers some path-based routing when you are thinking of application. If you are using an application load balancer, It has integration with other AWS services, and really you can set your own load balancer, but it's just, and it will be cheaper, but it's just complex doing it and maintaining it. It will not be high available. Scalability is a big problem. So more encouraged to use AWS elastic load balancers. And to wrap up, there are just 3 types of elastic load balancers in AWS. The application load balancer, and what you should keep in mind is operate at layer 7, support HTTP and HTTPS traffic, provides advanced routing features like path-based routing you can use in application load balancers. Network load balancers operate at layer 4. They handle TCP and UDP traffic, and they are suitable for low latency applications. The one that is already almost retired is the classic load balancer. Is the old version, and it used to handle HTTP, HTTPS, and TCP and UDP. I don't know how many people still create that, because AWS later on created these 2 load balancers as kind of an improvement in the classic load balancer. So most of the work created these days use either application load balancer or the network load balancer. Yeah. So that was a wrap up of the services we have covered, and actually the end of the material I had. Any questions so far on the last sections? I know I was, for time reasons, but I have the slides and I'm in the group. I try to catch up with the time. Any questions? If no questions, Olivier, I'll say over to you. Maybe you comment, please.
Yeah, thank you so much, Banjika. This I have to say, this has been a refresher for me, and also introduced other things that I haven't seen in a while. Definitely on the new VPC, different connectors that exist now. So it's really good to see. Thank you so much for this in-depth session. I hope everyone else enjoyed it as much as I did. We still have a few people online. We can do, there's 2 things we would like to do, of course. I prepared a little quiz just as we normally do, just as a practice. And a lot of things in the quiz definitely you covered because it was on the VPC. But I also added a few things in the previous 2 sessions. So some things on the EC2 and a little bit on the integrations that we covered last 2 weeks ago. So I'm now going to share that, and it's a short quiz. Hopefully we can go through it very quickly, and then we can do Banjika did prepare a feedback form that way he would like some feedback, so we can also take a few minutes to do the feedback form. Thank you so much, Banjika. So I will share my screen now for the quiz.